So now we will be looking at some rates of change for we're using with differentiation. So first, let's say a point is moving along the curve y equals 3x minus 2x cubed. Rate of change of x coordinate is 0.015. Find rate of change of y at x equals 2. So what we would do is, I would say that the rate of change of y is dy dt, and the rate of change of x is dx dt. T is time. So dy dt divided by dx dt, or is that the other way around? Yes, no, that's correct, is equal to dy dx, because it's multiplied by the reciprocal, eh? Yep. So dy dt will simply equal dy dx multiplied by dx dt. So that's 0.015 multiplied by 3 minus 6x squared equals 0.045 minus 0.09 x squared. So dy dt when x equals 2 equals 0.045 minus 0.09 times 2 squared. So that'll be 0.045 minus 0.36, which is negative 0.315, and that's units per second. And because that's negative, that would imply that y is actually a decreasing function. Prepare for the very sudden cut to the part 2. Now we'll move on to the final video in differentiation, and this is just a sequel to connected rates of change, and it's more practical applications. We're moving off the graph and more into quote unquote more real life situations. So say an oil spill forms circular patch, radius increases at a rate of 2 root r centimeters per second. Rate of area increase at 8 pi centimeter circumference. We need to find that out. So what I would say is, well, dr dt is 2 root r. Now we're trying to figure out dA dt, and that'll be equal to dA dr multiplied by dr dt. So let's figure out dA dr. So a is equal to pi r squared. So dA dr is equal to 2 pi r. So then our dA dt is equal to 2 pi r times 2 root r. So it's 4 pi root of r cubed, because exponent rules, root r is r to the half, r alone is r to the 1, so 1 plus half is 3 over 2, r to the 3 over 2 is actually the root of r cubed. So now we must figure out what r to use. And we can't just use 8 pi because that's the circumference. We want the radius, so we divide the circumference by 2 pi to get r. So that's just 4. So we do dA over dr when r equals 4 pi root of 4 cubed. So that's 8 times 4 is 32 pi centimetres squared per second. Now, again, as I said in a previous video, sometimes, say you have a cone, and it's a bit of water, and it's giving you the height. It also gives you the full height and the radius. Basically, you can use your similar triangles. This is a handy hint. Similar triangles to figure out what h is in terms of r. So you know that the ratio, and because r changes and you only want to be dealing with one variable, so you know that r over h is just the same as 10 over 30, which is 1/3, and you could use that ratio throughout. And it's the same thing with things like spheres. Just make sure you're getting it in one variable only. There'll always be enough information to go around. If you need, write out the formula for volume or area, whatever it is. Substitute in what you know, then rework it, rearrange it to get it one in terms of the other. So for sure, know your geometry formulas. Some of them are are given in the book though, but certainly, if you put in that substitute stuff in your volume formula or area formula or whatever, and you've got two variables in there plus constants, that's good because you can just rearrange it to put one in terms of the other. So all good. And then you can do that thing of substituting that in for the other one. So you only have it in terms of r or h or whatever you're using.